So in last 3 lectures, basically we have discussed different properties of real numbers. We have studied real numbers altogether again. All the definitions of addition and multiplication that we have been using for years, we cross-checked whether they are correct or not. What are the theorems, what are the postulates which support the different operations that we perform with real numbers. We have done that last 3 lectures, and now we are ready for developing totally new number system which will have the solution for the equation. That is the whole idea. The idea is, for why do we want to develop a complex number system? We want to have solution. Somebody is entering, Architesh Pandey. Okay. We want to solve something like this. X square plus 1 is equal to 0. We want to solve this, and present real number system does not have answer for this, and therefore we want to develop something new. Okay. Now, so basically the developing new number system is, one, to solve this. Second, what are the restrictions that we have while developing the new system? That we wish the real number system is not disturbed. Okay, so what all rules that we have developed for real number system, they remain intact. That is the second purpose. And third thing that we would like to definitely achieve is, if we are developing a new number system, we might as well define addition and multiplication. These are the two operations which we need to define, and hence if we do this, then we will say that yes, we have developed a complex number system where we have defined addition, where we have defined multiplication, and then this is the field that we wish to discuss. Okay, so eventually we will have complete development of complex number field, in which we will be able to finally say that yes, everything is answered. Now the first moment we say that the real number system is not to be disturbed, and we have observed last lecture that the real number line is exhausted. We don't have any space, because we want to have one-one correspondence between the numbers that we develop and its geometry of those numbers. So we would like to have parallel geometry work which is being handled. So we established up to real number, yes, real number line plays a very important role, and every real number has got a place on the real number line. Every point on the real number line has some label which is a real number, and there is a one-one correspondence. But now, till the real numbers, till rational numbers were developed, there was a space on the real number line, and therefore we could occupy that space. But now, as we discussed, there is no space on the real number line, and still we want to develop a new number system. Therefore, we do not have any choice but to move in the plane. And the moment you get into the plane, there are two axes and every point in XY plane is written as ordered pair x comma y. Okay, when it was a real number line, real number system, it was a straight line and every point was given by only one letter, no ordered. The more number of dimensions you add, ordered pair, order four numbers and so on. Okay, so this is one dimensional system. You have only one number in the bracket specifying the position of that point on that line. The moment you have ordered pair, you have two numbers specifying the position of that point. Exactly like two-dimensional geometry, x indicates the distance from y-axis, y indicates the distance from x-axis. So the new numbers would look like this. So new numbers, complex numbers will be ordered pair, right? Whereas real numbers were only one number and therefore we have to compromise. And hence now the real number system is not disturbed, but there is a difference between real number system and the complex number system that we wish to develop. They look different. It's order pair in complex numbers and it is only one number in real numbers. Therefore, if I say technically, if I say eventually after development of complex number, if I say real numbers system is a subset of complex number system, then it is a wrong statement. It is not correct statement. Why? Because I mean, if you are talking about subset, you are picking up some elements from this set and creating a new set. Maybe empty or total, all number, or maybe few of them. But subset is supposed to be, you are supposed to have the elements which are the part of this set. And you are creating a new set and therefore you are defining that as a subset. However, real number system, maybe if you write real number system, it will look like this, something like this. And complex number system, if you write, it will look like this, and so on. Therefore, technically, we cannot say real number system is a subset of complex number system. However, we want to restore the properties of real number even if we are dealing in complex numbers. Therefore, the bypass or the via media, stop share screen, whiteboard, Shaurya Johari add. Understood? Therefore, Samarth added. काय बाहेर जातात आते ते चालले काय? Okay, so eventually what we will say is real numbers, they are not the old real numbers, they are looking new near real numbers, will be subset of complex numbers. And what is so different in this is if real number set is 1, 2, 3, 4 and so on, then the new real number set that we are considering will be 1, 0, 2, 0, 3, 0 and so on. Okay, that is why I am putting this tilde over R, and I am going to recognize this real number system as a part of complex number system, but looking at it as ordered pair. But we know all the points are on the real axis or maybe x axis, therefore their y coordinate is going to be 0. And now This is a correct statement. We will say real number system is embedded in complex number system. Real numbers are embedded in complex numbers. Okay, that is what is the approach that we will take. That is the only way we can sort this problem out and go ahead with that, right? Okay, so at this stage what we have agreed upon is complex number will look like ordered pair. Complex number will look like ordered pair, and therefore let us write down two complex numbers. Complex number 1. Normally complex numbers are denoted by the letter Z. So let Z1 and Z2 be two complex numbers. Okay. Of course, Z1 will look like, Z2 will look like. Okay. Now here x1 comma y1 comma x2 comma y2, in this case what are these? X1 y1 x2 y2 belong to old real numbers. They are the real numbers. They are the representatives from the old system of your numbers, which is real number system, and now occupying the space in the bracket. We call it as ordered pair, and call it as a new number, which is Z1, complex number 1, complex number 2. So the idea is two complex numbers are equal. That is what is the definition. If and only if now this is the chance. Now this type of chances I will give you to think and create your own definitions, and go ahead slowly. We will go towards development of complex number system. Now this is a very simple job, therefore I won't spend much time on this. However, for defining addition, for defining multiplication, I will give you sufficient time so that you define those systems you yourself. Okay. So what is the obvious definition of equality of two complex numbers? Can somebody tell me? Can somebody tell me what should be the obvious definition of complex numbers equality?
x1 equal to x2,
x2, y1 equal to y2.
Yes, and that is true, that is correct. So two complex numbers are equal if and only if x1 equals x2 and y1 equals y2. So corresponding elements must be same. That is correct. So we can finalize that if we want to say two complex numbers are equal, their corresponding elements must be equal. Now what we want to do is define addition of two complex numbers. So next thing is definition of addition. Okay, can somebody of you suggest me definition of addition. I want to do perform Z1 plus Z2. What should be the definition of summation of two complex numbers? Any guess? Any idea?
x1 plus
Z3
x2
x1 plus
comma
x2
y1
and
plus
y1
y2.
plus y2.
Okay, okay. Definition of summation Z1 plus Z2 is equal to, it is going to be a new complex number which will look like, as you are suggesting, x1 plus x2 comma y1 plus y2. Okay, so it is defined as definition of addition Z1 plus Z2 is
सर हे बरोबर आहे ना?
add corresponding elements. बरोबर आहे ना? म्हणजे
नाही म्हणजे तुम्ही आता क्वेश्चन विचारलात ना, तर म्हणजे हे बरोबर आहे ना, x1 plus x2, y1 plus y2.
okay, so whether this is correct or not, I will not say whether it is correct or not. We have laid down the rules which we need to follow and check whether it is correct or not. So the moment we define addition, we should check A1, A2, A3, A4 and check whether they follow those rules or not. And if they follow, then yes. If they don't follow, then no. We will have to do the new definition. So, but before starting that work, I would like to make some things clear over here. Now, this is the addition symbol that we have used here. And the addition symbol that we have used here and here, okay, they are not the same. Okay, they are not the same. This additional symbol is the new definition that we are doing. Tomorrow you may say definition of addition and it will look like Z1 star Z2. That is fine. You can call addition as star. You can write addition as a star. Denote it by star, doesn't matter. However, now we cannot change this because we have fixed this. We said we assign A plus B, unique number, and read by A plus B, denoted by A plus B, looking like this. So this is our definition of addition and this symbol of real number addition. And this is the symbol of complex number addition. So this is what we are defining now. And for convenience, we are not changing the symbol. We are not changing the symbol and we are not creating something new for addition. We are not doing that. We are keeping it same. But consciously, we are aware that this addition and this addition, they are not the same. They are different. This is addition of older real numbers. However, this is addition of complex numbers. Okay, so that part need to be understood. I mean, it is eventually addition will behave like summation only, like real numbers only, but we have to be thorough with what we are discussing. So now you may require Z3, which I will provide you. Z3, X3, Y3. Now run through A1, A2, A3, A4. Okay, check commutative property, check associative property, find out additive identity, find out additive inverse. Complete this activity and tell me whether this addition definition is okay with you or not. If okay, what is additive identity? If okay, what is additive inverse? Okay, so this is the work which is to be done by you. So I wait for some time. Okay, A1 talks about commutative property of two complex numbers. So we have to cross check whether Z1 plus Z2 is it equal to or not Z2 plus Z1. And obviously, if we are using the definition of addition just like that of real numbers, then commutative property will be true. Similarly, associative property also will be true. Z2 plus Z3 is equal to Z1 plus Z2 times plus Z3. This also will be true. Now, A3 says additive identity. So you want to have Z1 plus additive identity, say Z, such that you end up getting Z1. So if you use the definition of addition now, you will come out with 0, 0 as your additive identity. Okay? And additive, as far as additive inverse is concerned, you take Z1 plus add Z1 dash and you should get additive identity, which is 0, 0. So of course you will get, if Z1 is X1, if Z1 is X1, Y1, then Z1 dash is going to be opposite of X1, opposite of Y1, right? So all four, A1, A2, A3, A4, everything is gone through. Therefore we can say that, okay, addition of complex numbers can be defined like this. Very good. Now the next step is definition of multiplication. Okay, so what we would like to write in LHS as Z1. Now this is a new symbol, multiplied by Z2. This is definition of this new symbol, and we want to keep it same as multiplication of real numbers, or maybe we can write it as Z1 dot Z2, and it is open to you now to think about the definition and let me know. Now it might happen that few of you have learned complex numbers before, not in this way, but just gone through the literature, read some books, and you know the definition of multiplication, which is conventional or which is being eventually used. But that is not expected. If you know, you keep it to yourself. If you were given the task of developing the new definition of multiplication, what you would have done, that you should do now. Okay. Now, let me tell you, at this stage, we had one student 10 years before, her name Mrudul Thatte. She came out with altogether new definition of multiplication of complex numbers. And for all practical purposes, the new definition of the complex numbers or multiplication which she thought of could develop altogether a new set of complex numbers or new way of thinking about complex numbers. The rules for that system will be totally going to be different than the rules for the conventional complex number system eventually, which we will follow.
सर आवाज येत नहीं है.
काय होत नाहीये? काय होत नाहीये? ऐकायला येत नाहीये?
आता येतोय.
आता येतोय, मगाशी ब्रेक होत होता.
Okay, so this is the opportunity given to you to think and come out with new definition of multiplication. It is couple of seconds job for me to tell you what multiplication of complex number is supposed to be by definition. But I am not going to do that. I am going to ask you to think and come up with your own definition. Therefore, I am warning those who already knew the definition of multiplication of complex number. Those who do not know should try. Keep trying. Maybe you will fail a couple of times. That is fine. but you should try and come out with your own definition of multiplication. Now, how do you know, how do you test whether your multiplication definition is good enough or not? It should satisfy M1, M2, M3, M4. So if you come out with new definition of multiplication, what you should say, yes sir, M1 is satisfied. Yes sir, M2 is satisfied. Yes sir, M3 is satisfied, and this is what is multiplicative identity. And M4 is satisfied. This is how multiplicative inverse is to be found out. So these are the 4 questions that you need to answer by your own definition of multiplication. Okay, so whatever your definitions that I have seen, essentially the most logical definition of addition was addition of corresponding elements which worked for A1, A2, A3, A4, and therefore obvious definition for multiplication as per you would have been Z1 multiplied by Z2 is equal to X1 into X2 comma Y1 into Y2, right? So as far as M1 is concerned, commutative property, it will pass. As far as M2 is concerned, associative property, it will pass, not a problem. But as far as M3 is concerned, let us discuss M3. Let us discuss M3. What does M3 say? If you have any complex number Z1, which is equal to X1 comma Y1, then if you multiply it with another complex number Z, which is again going to look like ordered pair, let me call this as UV, and maybe we will have to say here that UV, this complex number, is not equal to 0 comma 0, because that is what we had been saying in M3. In M3 of real numbers, this number was 1, and we said 1 is not equal to 0. So the new multiplicative identity that we are going to find out is not equal to the additive identity that we have already found out. That is what we have to mention here in M3. Suppose we mention, then what eventually you will get? You will get, you want X1, Y1 back. Is that right? That is what is M3. And therefore, your obvious choice for you, so you at this stage what you will say, M3 gives us multiplicative identity which is equal to 1 comma 1. And you will say that yes, with 1 comma 1, M3 is true. Now let us check M4. M4 says X1 comma Y1, that is Z1, if multiplied by U comma V, a new complex number, which eventually we will call multiplicative inverse, should produce, what should it produce? The multiplicative identity, 1 comma 1. Yes, that is what is our M4. Now let us check whether M4 works or not. If we define it like this, then X1U comma Y1V should be equal to 1 comma 1. That means U should be equal to 1 upon X1 and V should be equal to 1 upon Y1. Oh, fail. Why will it fail at this stage? Why will it fail at this stage?
If x1 is equal to 0 or y1 is equal
Because
to 0.
if x1 is equal to 0, if y1 is equal to 0, then it will fail. We can say, okay, I mean, we will get it through by saying if x1, y1 not equal to 0. That is what, I mean, you have been alert in showing your answers and you showed the answers like this. But that is okay. I mean, you have passed M4 by keeping X1 and Y1 away from 0. But in turn, what are you doing? Do you realize? You don't want X1 to be 0. You don't want Y1 to be 0. That means you are eliminating all real numbers on x-axis, all numbers on x-axis, and eliminating all numbers on y-axis by just writing this statement here. By writing this statement here, you are eliminating these important numbers. All the numbers of the kind x comma 0 and all the numbers of the kind 0 comma y gone out of the system. That is not good idea. If it was a one of a kind number, maybe only consider 0 comma 0 separately, sir. That is the culprit. We will have to deal with it little differently. Yes, we can consider. But if you are saying ignore x-axis, ignore y-axis, then there are infinitely many numbers to be ignored. Then the definition is not really versatile. It is not good. That is one part of the story. That is one part of the story. But the most important part of the story is that have we achieved the objective that we wanted to have eventually. So let us accept this definition by deleting these numbers. Let us, if at all, if we accept, then what do we want? We want a complex number. We want complex number z, with which if we multiply z, should produce -1. That is what is our requirement. So in complex number and ordered pair system, it will happen like if I have got a complex number x1, y1, xy, if I multiply it by xy, then as per your definition, it will be x square comma y square, and we want this x square comma y square to be equal to -1, and -1 is our real number, therefore we convert it into ordered pair like this. If we do this, then we get, okay, y is equal to 0, satisfied. Y will satisfy this. However, we have to solve and get x square is equal to -1. The solution of this is going to be going and sitting in this place. But that is what we are trying to solve. Back to square one. Do you realize this? That by this definition, we are not going to develop a system because we cannot solve this example. This is the simplest equation which we want to solve. That is what we have written. We have a couple of objectives of doing complex numbers. One of the objective was to have, where are those objectives? Oh, this was the first objective, to solve x square plus 1 is equal to 0. We are not achieving it by this definition of multiplication, so it is not good. No good. The definition is no good. So, okay, first attempt is gone. Attempt number 2. Okay, I pause the video, I give you sufficient time. Think about it, come out with new definition. Okay, so after spending good amount of time, now I am not still going to disclose the answer. What I am going to tell you is, in LHS, you have x1, y1 multiplied by x2, y2. Okay, and that is what you are trying to define. So the ordered pair that you will create, you have already tried of creating x1, x2, comma y1, y2, and it fails because Basically, commutative and associative, they are the easy properties to satisfy. But M3, M4 are important. M4 essentially is more important because you cannot end up having scrapped few real numbers. You cannot really scrap them. Each and every real number has to be part of complex number system. That is one part. Therefore, M4 is important. And the most important is solving this equation. So therefore your multiplication is going to be some combination, because we only know the addition now. Therefore addition or subtraction or multiplication of real numbers, it will be the x coordinate will be function of f1 of x1, x2, y1, y2, and this will be function of x1, x2, y1, y2. If you try this, then you might end up getting suddenly a definition which will work for M3, M4 and this. So we really do not know how many years these mathematicians must have done, how many trials to get this definition of multiplication in place. We are doing it in one lecture, but they must have spent good amount of time on it. But now I am allowing you to spend at least 5 minutes, 10 minutes, 15 minutes. So who knows, by some trials of combinations of these four numbers x1, x2, y1, y2 for x coordinate and similar combination, some combination for y coordinate, suddenly you will pass okay. So that is good part about this whiteboard, that it is there intact. Can you listen to me? आवाज ऐकायला येतोय का?
Yes, sir.
Is recording on?
Yes,
Yes,
sir.
sir.
Yes. Okay. So what I was trying to tell you is, you come up with some combination of x1, x2, y1, y2, x1, x2, y1, y2. So suddenly you will realize that m1, m2, m3, m4 is satisfied, and you have a solution for x square is equal to -1. Give you sufficient time, some more time. Anyway, internet connection is weak. Some more time for thinking. Think about it. Now, after so many trials, what definition eventually will work is x1, x2, y1 into x2, y2 is defined as x1, x2 minus y1, y2, x1, y2 plus x2, y1. Okay, now I will do the work for you. M1, x1, y1 into x2, y2, is it equal to x2, y2 into x1, y1? Observe, each term has got 1 and 2, 1 and 2, 1 and 2, 1 and 2. Therefore, even if we change the order, this will continue. x1, x2 will continue to sit here, minus y1, y2, and therefore m1 is through. M2, x1, y1 into x2, y2 multiplied by x3, y3. Let us try to find out this product. It is x1, y1 times x2 x3 minus y2 y3 comma x2 y3 plus x3 y2. So one more step, this into x1 x2, we have to follow this definition. So x1 into this that is x1 x2 minus y1 into x2 y3 plus x3 y2. This is your first coordinate, comma second coordinate x1 y2, that means x2 y3 plus x3 y2 plus x2 multiplied by x2 multiplied by, नाही काय करतोय मी आता, बरोबर चाललंय, नाही इथे काय पाहिजे,
y1 multiplied
x1 x2 झाला मायनस y1 y2 झाला. आता x1 y2 लिहून झाला आणि काय लिहायचं आहे x2 y1, बरोबर. सो x2 इनसाइड ब्रॅकेट
Sir, it shouldn't be x2, it should be y1.
No, it should be y1 outside and then the bracket inside. Okay, this should be y1 and you should have x2, that means this bracket x2 x3 minus y2 y3. Is that right? This is our order pair. Now if we simplify it little bit, we will get the idea that yes, x1 x2 x3 minus x1 y2 y3 minus y1 x2 y3 minus y1 x3 y2. This is the first number and the second number is x2 x1 y3 plus x1 x3 y2 plus y1 x2 x3 minus y1 y2 y3, right? Okay, so this is what is the association of LHS, and RHS will be x1 y1 into x2 y2 multiplied by x3 y3. Now I don't do this on the board right now, but you can always cross check that this is indeed equal to this. If you just write down all the three terms exactly the way we have done it for LHS, you will find that M through it will pass without any problem. I leave it to you. M3. M3 says if you have x1 comma y1 multiplied by something u comma v should give you x1 comma y1, right? So now our definition of multiplication is x1 x2, therefore x1u minus y1v and x1v plus y1u should be equal to x1 y1, and therefore we are supposed to search what is u and v. So this is two equations, two unknowns. X1 is equal to x1u minus y1v and y1 is equal to x1v minus y1 or plus y1 u. Okay, solve simultaneously. You will get u is equal to 1 and v is equal to 0. Okay, मला सांगू शकताय? I can wait for some time. Can you cross check and tell me whether this is true? We can verify. Okay, if u is equal to 1 and v is equal to 0, then the first equation is satisfied. Yes. And if u is equal to 1 and v is equal to 0, of course second equation is also satisfied. Yes, that is very good. So u is equal to 1 and v is equal to 0 is very, very important for us, and it is what we will call it as multiplicative identity, which is 1, 0. Now, here we should be happy about this multiplicative identity, because if we say, oh, we compare this complex number system with real number system, then in real numbers, multiplicative identity was 1. And now in complex number, it is becoming 1, 0. So it is good. Happy situation. Something similar is happening here. Therefore, might be this definition will work. Okay. So what is M4 now? Let us write M4. Let us use maximum number of colors. M4. M4 talks about x1, y1 multiplied by u into v, u comma v is equal to 1, 0. You should get in RHS multiplicative identity. Now, this is going to give us again two equations. x1u minus y1v is equal to 1 and y1u minus or plus x1v is equal to 0. Right? Now, if you solve them simultaneously, you will get u is equal to x1 plus y1, sorry, u is equal to x1 upon x1 square plus y1 square, v is equal to bola minus
y1
Minus y1 upon
minus
x1
y1
square plus y1 square.
x1 square plus y1 square. So M4
Sir, but for that we need the definition of inverse.
before that
We need to show x1 square plus y1 square has an inverse.
x1 square plus y1 square has an inverse. No, I don't understand what you are saying.
Sir, M4 is to show that each number has an inverse. But if we're taking inverse of x1 square plus y1 square in this, then we're going back in the same loop.
No. So therefore, I'm not jumping. I'm doing it systematically. I did M1, I did M2, I am doing M3, I am doing M4. And of course, I will cross check now whether this is true or not. Or we are going back to loop. Okay. So the right step is to find out u and v first. Okay. Now, the multiplicative identity that you have got here, multiplicative identity, in M3 we should have said, yes, 1, 0 is not equal to 0, 0. That is the additional thing which we need to write in M3, which we forgot, where we have to say that multiplicative identity is different than that of additive identity. Okay. That is the only point which is remaining. Otherwise, everything is correct. You have got u and v. Now we will cross check whether are we in trouble for any values of x1 and y1. Are we in trouble for any values of x1 and y1? And now we realize that
0,
0, 0.
in case
0,0.
x1 comma y1 is equal to 0 comma 0, multiplicative inverse is not defined. Okay, again we should be happy about this because this is something similar to multiplicative inverse in real numbers, not available. And here we are saying multiplicative inverse of 0 comma 0 not available. So we should be happy. Array, it is going hand in hand. No issue. Happy about it. But for every other number, we are just removing one out of infinitely many ordered pairs and saying that we fail to give you inverse of origin 0 comma 0. That is fine. That is not a big deal. We are achieving much more than what is required. So now M1, M2, M3, M4 is through. We have got multiplicative inverse. So let me write down multiplicative inverse. Which will look like x1 upon x1 square plus y1 square plus y1 upon. Okay, so now only Agni Pariksha remaining is if you multiply the same number to the same number. So let us multiply u into v to u comma v to u comma v. Our definition says u square minus v square comma twice uv. This is what is this is z square, u square minus v square twice uv. Now we want this number to be equal to minus 1 comma 0 because we have decided all real numbers to write like this and we want root of minus 1. So in complex number system, minus 1 will look like minus 1 comma 0. So if this is the case, then equality of two complex numbers, this implies 2uv is equal to 0. So if I take v is equal to 0, if v is equal to 0, then u square is equal to minus 1 back to square 1. No, but if u is equal to 0, then minus v square is equal to minus 1. Which is equal to v square is equal to 1. Very good. Which is implying us v is equal to plus or minus 1. And therefore, the complex number z whose square is u is equal to 0 and v is equal to plus 1 or u is equal to 0 and v is equal to minus 1. Oh my God. We wanted 1 square root of minus 1 and we got 2. We should be happy because in real numbers, if you take square root of 25, it is plus or minus 5. Similarly, if we want a square root of square root of, that means minus 1 comma 0 bracket square is equal to, बरोबर चाललंय ना मुलांना? नाही चाललंय, मी लिहितोय z is equal to पाहिजे ना हे. This should not be z square is equal to this, it should be z is equal to this. Z square should be equal to minus 1 comma 0. Therefore z is this. So this is where we can be very happy about, and where we can actually say hooray. Because we have found out the complex number. Birth of complex number has taken place. It looks like 0, 1 and 0, minus 1. So if we square 0, 1 or 0, minus 1, we will end up geometrically. If I want to show you, I don't know whether this sheet will further move up or not. Yes, areva. So geometrically, if I want to show you that if you are sitting here, this is 1, 0, this is minus 1, 0, this is 0, 1, and this is 0, minus 1. अरे तुम्ही वाईट बोर्ड वापरू नका माझा. So if we square this complex number, we go and sit here. If we square this complex number, we go and sit again here. So this is denoted by positive I, which is iota, imaginary number, IOTA. Is that correct, Sudhin? I think so.
Yes, sir.
This is plus I and this is minus I. The name is given plus I or minus I. Okay, and this is the treatment for generating complex numbers, which is Prakash sir's method of teaching complex numbers. You will not find this kind of process. For 2 hours we are doing this and getting finally the number whose square is minus 1. It is not upsetting our M4, it is not upsetting our multiplicative identity. All inverses are in place except 0, 0. Every number can be regularized, can be managed in complex number system. And we finally got a complex number whose square is minus 1. So we can solve the equation x square plus 1 is equal to 0. Okay. And now the most important thing in this lecture is we have not talked about I last minute. We have given the name to that ordered pair as I and opposite of I. We have not considered I. Consider a complex number whose square root is minus 1, whose square is minus 1, and then we start processing that complex number. That is the treatment you will find in each and every book. That is how we are not going to develop a complex number. Now, this is the proper method of getting it. Now, what is only difficulty in this particular treatment is if you do not get that definition of multiplication x1 x2 minus y1 y2 comma x1 y2 plus y2 x1, then it might take long to develop the system. But you realize at least 3-4 students in this class, and given some more time for you guys also, you could have come out with some combination of x1, x2, y1, y2, which will satisfy the multiplication definition and will give us the root of minus 1. अरे समजलंय का काय मी बोलतोय ते? बोर्डवरती जे जे काय लिहिलंय ते समजलंय का तुम्हाला? ओके. So if you have copied everything that is there on the board, maybe we will figure out what is pending is whether distributive property is working or not. We have not checked because that property we will require. So maybe I have 10 more minutes. Let us try to write down that expression and check whether D is also satisfied or not, because that is the only thing which is pending.
Sir,
Yes, yes, bolo.
now can we write that Z is equal to x plus iota into y?
That we will write next lecture. We have to legalize it. Why should we write it like that? We need to talk about it and then only we will write it. It will work because it has been working like that. But then how and why do you think of writing it like that? Some discussion need to be done on that. We will do it in the next lecture and legalize it, and then we will quickly start doing algebra of complex numbers very, very quickly. Okay, but in the remaining time today, let me finish the distributive property of the multiplication. So I will need three complex numbers. Oh, I will need three complex numbers, x1, y1 into x2, y2 plus x3, y3. So LHS is equal to x1, y1 into x2 plus x3 comma y2 plus y3, which is equal to x1 into x2 plus x3 minus y1 into y2 plus y3. This is the first coordinate, comma, then x1, y2, x1, y2 plus y3 plus y1, x2 plus x3. That is how your LHS will look. And RHS is going to be x1, y1 into x2, y2 plus x1, y1 into x3, y3. Now let us cross check. What is this multiplication? x1, x2 minus y1, y2, comma, comma काय? x1, y2 plus y1, x2 plus x1, x3 minus y1, y3, comma, x1, y3 plus y1, x3. Now if we add them, let us write down here. If we add them, we will get x1, x2 plus x1, x3 minus y1, y2 minus y1, y3. That is the first number. And second, x1, y2 plus y1, x2 plus x1, y3 plus y1, x3. बरोबर आहे? And if we expand this, we get exactly same. hence D satisfied. Okay. So what we can conclude by saying that as addition and multiplication definitions satisfy first 9 properties, all theorems up to O1, O2, O3 are proved. Annihilation theorem will work for complex numbers. Left cancellation law will work. Uniqueness of additive identity, yes, it will work. Uniqueness of additive inverse, yes, it will work. All these theorems that we have proved up to O1, O2, O3 will go through without any problem. Okay, but then how about O1, O2, O3, etc.? We have to keep on discussing, but I think today is a good job that we have done so far. And do you have any questions on whatever work we have done today? Internet is struggling, speed is not that good. If you have questions, quickly ask me questions. Otherwise, we are going to stop.
Sir,
Yes.
sir, in the above, we had two cases that u square is equal to -1. That case is left unsolved, right? So,
U square is equal to -1 is unsolved. Where is it? कुठे गा? हे गा? This is what you are talking about?
ho.
So it is not unsolved. It is useless situation because we are back to square one. That is what I am trying to say. I mean, if we consider v is equal to 0, then we are not achieving anything. Back to square one means we are not achieving anything. Therefore, it is solved. I mean, we have solved it. I mean, we have solved it means at this stage we cannot solve this equation, and therefore whatever work which we have done so far is useless. If that was, suppose this similar situation was happening for v square also, then go back and define your multiplication once again. That is what is going to be the alternative. You cannot do anything beyond that. But here, fortunately, what has happened is, even if u square becomes -1, and if we scrap this system, we had another option. Another option is, you make u is equal to 0. Either v is equal to 0 is not giving us the answer, and it is u is equal to 0. So either u is 0 or v is 0. Both of them are real numbers. And therefore, the moment we keep u is equal to 0, we got the solution. समजलं?
सर पण आपल्याला तेच शोधायचं होतं म्हणूनच आपण हे केलं ना
हो
कॉम्प्लेक्स नंबर सिस्टम्स
हो
फाइंड आउट करायला
मग झालं ना, मग सॉल्व्ह झालं ना. आता हे शोधायचं ते झालं ना काम शोधून. इथे जाऊन प्रत्येक डेफिनेशन इथे जाऊन अडकत होती इतर केस मध्ये. या डेफिनेशन मधनं आपण इथे झालेलो आहे. ठीक आहे. एनी अदर डिफिकल्टी क्वेश्चन?
आज तुम्ही एक्झाम
येस
सर एक्झामचं स्ट्रक्चर सांगणार होता.
एक्झामचं स्ट्रक्चर, देर विल बी 30 प्रॉब्लेम्स to be solved in 20 minutes, 22 hours. All problems will be numerical type. You can have 5-digit answer also. All answers will be integers, positive or negative. It could be 1572 answer. ठीक आहे, डिस्कनेक्ट होणार आहे कारण मी फोनवर आहे. बाय, एंड द मीटिंग.